Hi, my name is Muhammad Iman bin Mosharum, and I will presenting about the chapter 1 for this project, group project. So for the introduction, for this project, students are required to form a group of 4 or 5 for design their own unique second order system based on the combination provided. And based on the selected system, students are required to construct a system diagram that represent a second order system and to assign all variable and parameters suitable for the system. Students need to derive all relevant mathematical equation through combination of appropriate physical laws and assumption. Block diagram and signal flow graph of the system are needed based on the set of the equation that we obtain. So for the objectives, there are several objectives that we can conclude in this presentation. So for the first one is to analyze the stability, steady state error and transient response of control system using the appropriate methods. Demonstrate analysis and design a physical system using time and frequency response method to the practical application in control system. And lastly, the third, the execute problem solving methods and verify the concept covered in basic control system via hand calculation and simulation in computer aided software in group project. So for the scope of this project, it's mainly to solve a model which is in this project is we choosing the electrical system, rotational mechanical system and a gear system combination. Design its own unique second order system, construct the system diagram and assign all variable and parameters suitable for the system and obtain the transfer function of the system. We also need to solve this system by calculating the settling time, rise time, steady state error and the overshoot of the systems. This system is assumed as a second order and derivation of mathematical by using block diagram or Mason's rule and obtaining its transfer function. The scope of this project is also aimed to comparing the result that have been calculated to investigate the closed loop response for the system. That's all from me. Thank you.
Good morning, sir. I am Teacher Chong. Today, I will going to present for the chapter 2, Mathematic Modeling of the System. First, we need to know for the amateur circuit and some parameter which important in the system is shown. And from the amateur circuit, we can get some equation and we can derive it like this. And for the block diagram for the amateur circuit is shown. And with assumption that the motor generator is proportional to the armature current. And from this, we can start to derive our equation Tf equal to Bm omega t is equation 1. And for the Newton's second law, we can find out one more equation. And dmt negative Tf equal to Jm bracket omega n divided by dt. And we substitute equation 1 to equation 2 and we can get one complete equation. And for the diagram, it shows if the equivalent block diagram for the circuit, the back EMF is proportional to the angular speed for this system, and we can make an assumption. It shows, and the equivalent block diagram will be show the transfer relating the angular speed and the displacement, and transfer function of the back, and the complete for the circuit is shown by of the motor. The complete circuit, but for the calculation we need to sub t equal to 0 and the block diagram will become the complete block diagram and we can start our reducer and to make for the equation. And from the circuit we can produce some equation which is show data equal to Va equal to Kt SRS plus JMS plus PM plus KT KB. Thank you. This for the part for the mathematics modeling.
Hi, I'm Yuan Zhen, and I'll be presenting about chapter 3 of the calculation and the method. So, the theoretical calculation related to the transfer function is when we take the circuit of the servo motor, DC servo motor, we apply ds equals to 0, which is there's no disturbance. So after we use the block reduction diagram, we apply unity feedback system where the feedback equals to 1. So our H3s is equal to 1. and then we'll get this transfer function. So after this transfer function, we can use this transfer function and substitute all the values needed in the transfer function, but we let kb equals to 1, kt equals to 1, and bm equals to 0.1. These are all the coefficients that we can cross-check in the internet, and then after that we'll get this transfer function where we can compare with the second order of the control system, where 1 equals to omega n square, 0.1 r plus 1 equals to omega n square, and 2 because we need this to be undamped condition where damping ratio is 0.5, so 2 zeta omega n equals to rjm plus 0.1 L, and then substitute the damping ratio is 0.5, so we'll get L equals to 10, and ljm is equals to 1, so 10 jm is equals to 1, jm is 0.1, and all the parameters are summarized here. So the transfer functions is simplified to this. Hence we can use this to put the unit step input, where the G4 is equals to Ts equals to 1 over S. So Ts is 1 over S, we just shift up and times it, as shown in this block diagram, where we times that. And so we will get a new equation where we can compare to this partial fraction. After we've done a partial fraction, we can get k1, k2, k3 equals to -1, -1, and 1 simultaneously, respectively. So expanding the partial fraction, we can get this. Taking the inverse, we will get this. And from that, we can, after the unit step input, we can get the transfer function of rise time 1.68, peak time 3.628, settling time Ts equals to 8, maximum overshoot is 0.837, percent overshoot is 83.7, which is quite high, but it's okay. It will be done in the conclusion later. So the result will be discussed in the discussion part, and it will be done in the conclusion, where we recommend what should be done in the transfer function due to the maximum percent overshoot. Thank you.
And hi, my name is Wan Nasrul Nizam Biwan Hussein, and I am gonna explain about the chapter 4, which is about the computational analysis using MATLAB. Okay, the graph here show is we are obtained from the MATLAB analysis after we key in our transfer function, and the result we make a comparison between the MATLAB analysis and theoretical calculation, and overall the result shows it's almost the same, except at the overshoot percentage, which is have a bit different among this. And here is the block diagram that we obtained from the MATLAB. And for the compensator design, we are designing the block diagram into the MATLAB Simulink, and we install the PID controller into our block diagram. Then after we tune our block diagram, it shows we achieve the zero steady state error at the settling time is 2.75 seconds. And here is one of the simulation results that we obtained from MATLAB after we tune for our block diagram. And here show the PID coefficient that's suitable for our block diagram to achieve zero steady state error. Okay, that's all from me. Thank you.
My name is Mao Chun. Now I'm going to present my part conclusion. In conclusion, we have achieved the objective of this project. We have successfully studied and planned physically structure using theoretical equation and test by using MATLAB. From this studies case, we can infer that the undercut state method, which is commonly used in mechanical system, it can be well described and replicated on a machine. to replicate a real-life application and forecast various conditions and output. For the recommendation, the PID controller are used to boost dynamic responsive and minimize or remove steady state error. The improvement benefits decrease the change in rise time and the steady state error. Meanwhile, for the PID controller doesn't eliminate the steady state error but only improve it. It's highly recommended that the design of the PID compensator be used as it prevent overshooting, eliminate the steady state error and reduce the setting time. That's all from me. Thank you.